This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Routing is the term used to describe the process of connecting two distant nets on a PCB. The process called routing connects various types of objects on a PCB. It can establish connections between pads, vias, or tracks. You can manually connect them, but now we will learn the faster way using interactive routing tools in Altium Designer. In this video, we will demonstrate how to connect objects on a PCB using interactive tools. These interactive tools are powerful because they automatically define the possible path of your connection while you are routing. Take a look at this example. Just launch the command and click on the object you want to connect, and it will automatically determine the connection path based on the movement of your mouse cursor. Now, if you consider the trace width of the track you'll use in routing traces, it is set in the routing width design rules. Similarly, the considerations for clearance are set in the clearance design rules. The way the interactive router interacts with existing objects like pads and routing on the other nets, it is determined by the current routing conflict resolution mode. This mode dictates whether the router will walk around the obstacle, attempt to push it, stop, or ignore it. Cursor-guided routing enables efficient and intuitive manual routing around obstacles. In simple terms, you use your mouse to create the route's path, and the interactive router automatically places the tracks along that path. This process adheres to design rules and considers various constraints for track placement and corner types. Interactive routing can be done on three types of nets. First, single net. As the name suggests, it refers to individual nets that are routed individually. To route a single net, simply go to the toolbar, click on the Route button, and select Interactive Routing. Click on the first object where the origin point is located, and then connect it to the second object where the endpoint is situated to complete the connection. Next is the differential pair, which is commonly known to everyone. It refers to a pair of signals that needs to be routed together simultaneously. To accomplish this, just click on the Route button on the toolbar again, and then select Interactive Differential Pair Routing. And the last type of nets that you may encounter while routing is the multi-nets, or the selected multiple nets. These are multiple nets that you can encounter together as a group. To route this type of nets, you first select the multiple tracks that you want to route together. Then, click on the Route button on the toolbar and choose Interactive Multi-Routing. When you initiate interactive routing, the PCB editor will keep track of the cursor position and mouse clicks while applying all relevant design rules. It will trace your cursor path while minimizing the number of actions needed to place sections of routing. While routing, click to place the tracks up to the cursor, and then continue moving your cursor and repeat the process. This ensures that the software precisely follows the path you have chosen. If you go too far before committing the tracks, it's possible that some portions of your chosen path may be altered. Now let's explore the properties of interactive routing. We can access its properties by pressing the Tab key while the interactive routing command is activated. You first click the Route button in the toolbar, then select Interactive Routing. After that, click anywhere on the board and then press the Tab key on your keyboard. The Properties panel will appear on the side, containing settings that you can modify to customize the way you want to route. The first setting we will learn about is the Routing Conflict Resolution mode. The response of the interactive router to objects already present in the PCB workspace such as pads and other nets varies based on the current routing conflict resolution mode. First is the ignore obstacle option. In this mode, the interactive router will completely disregard any objects that your cursor comes into contact with. You can freely route in any space of the board without any restriction. However, violation may still be present and they will remain visible despite this mode is being activated. Next is the push obstacle option. In this mode, the interactive router will automatically push any object that comes into contact with your cursor while the interactive routing is active. Next is the walk around mode. It will try to find a route around existing objects such as track, pads, and vias. The clearance to the other object is determined by the relevant clearance design rules. Next is the stop at first obstacle mode. In this option, the router will automatically halt when it encounters the first obstacle before continuing the routing process across the board. The last mode in the config resolution option is the hug and push mode. In this option, the router will hug the object when it comes into contact with, before pushing it aside to create a path for the trace that you are routing. Knowing these conflict resolution modes can indeed be helpful as they serve as a guide to simplify your routing experience using Altium Designer. Understanding when to use each mode can make your routing process more efficient and tailored to your specific design needs. Now let's discuss corner styles. When routing a board design, there are various corner styles available based on the requirements and the desired smoothness of the trace you want in your layout. So first is the 45 degrees corner style. In this corner style, the corners have a 45 degrees angle. And here's the 45 or 90 with an arc. Next is the 90 degrees corner style. This is where the corners have sharp angles. Next, this is the rounded version of the 90 degrees corner style. This is where the corners have an arc shape. And this is the any angle corner style. This is where you have the freedom to choose any angle you prefer. It is also known as freestyle routing because you can route the corners with any desired angle without being constrained to predefined angles. Now let's move on to the keyboard shortcut keys. This is when you are in the design phase where you will be routing. So first is the spacebar. Spacebar is used when you want to change the direction of the routing corner of the trace that you are currently routing. Next, if you want to change the conflict resolution mode without going to the Properties panel, simply press Shift+R on the keyboard. Ensure that the routing command is active before using this keyboard shortcut. You will see the routing mode changing in the lower left corner of the interface. Next, if you want to cancel the currently active command while routing, you can either right-click your mouse or press the Escape key on the keyboard. This will quickly cancel the active command. To change the routing corner without going to the Properties panel, simply press Shift+Space consecutively while the routing command is active. You will physically see the routing corner of your trace changing as you use this keyboard shortcut. Next, if you are in the middle of routing, starting from pad or via and you realize that you are on the wrong layer, simply press the L key on the keyboard. The routing command will automatically switch to another layer when you press the L. Next, in the board design process, fan-out of connections from a component is essential. To quickly add a via while placing the fan-out trace, simply press the number 2 key on the keyboard. This will automatically create a via at the specified location. In routing, there are instances when two connected points are located far apart. To simplify the routing process, activate the routing command and press the control key. Then left-click the mouse to complete the routing between the two distant points. Next, if you want to change the trace width without going to the Properties panel while the routing command is active, press Shift plus W on the keyboard. This will bring up the options for the trace width, where you can select your desired trace width. Last is when using multi-routing. While in multi-routing mode, if you want to decrease the space between the traces, press the B key on the keyboard. On the other hand, press Shift plus B if you want to increase the spaces between the traces. We are done with today's video about routing techniques and tips in Altium Designer. There's still a lot more content to explore in this topic if we delve deeper, but these are some of the important information about routings. That's all for now, and make sure to watch other videos to learn more.